Okay, this is part 2 of the day's video. The next thing we're going to talk about is Pythagorean identities, and that's basically saying that if you take the horizontal side in your triangle and you square it, and add it to the vertical side in your triangle and square it, you get the hypotenuse, which on a unit circle is always 1. We've been drawing these triangles and labeling the hypotenuse as 1. So, what does that mean here? Well, okay, first of all, we have to figure out what quadrant we're in. So if I have an angle T that's between 0 and pi over 2, that means on the circle, here's 0 and here's pi over 2. So I'm somewhere in this range right here in the first quadrant, okay? Now, if the sine of that triangle is 1/2, what I'm going to do is I'm just going to draw a first quadrant triangle. So, let's see. This is the center of the circle. The first quadrant would be up and to the right, so I'm just going to draw an angle that way. And then I'm going to draw an angle, or a line back down, and then back again. So this is my central angle. So if you draw the whole circle, it's kind of like this. Okay? So that angle is rotated up into the first quadrant. Now, do I know exactly what it is? No, but it's somewhere in the first quadrant, and that's good enough to make our diagram. Now our sine, which is our vertical side, is 1/2. And that tells me that this corner has to be pi over 6, otherwise known as 30 degrees. Because that's what side is always opposite that. And this is a right triangle, so this one would have to be pi over 3, otherwise known as 60 degrees. So this side would have to be square root of 3 over 2, and the hypotenuse has to be 1. They want to know what cosine is. Cosine is just my horizontal side here. So the cosine of angle T is going to be the square root of 3 over 2. Given that sine is square root of 55 over 8, and again we're in the first quadrant, see? So I'm going to, draw my triangle. Here's the central angle somewhere up into the first quadrant, and back down to the x-axis, and back to the origin. This time they're giving me the sine. Again, that would be my y value. That's up here, square root of 55 over 8. And then, this time I'm going to have to do it a little differently because clearly I don't have a 30, 60, 90 triangle or a 45, 45, 90 triangle. So, what do I do to find the other sides? Well, what I can do is I know that the sine of an angle squared plus the cosine of that same angle squared should equal 1. Okay, so if I take the square root of 55 over 8 and square it and add that to the cosine squared, that should be equal to 1. So I'm going to square this first. Square root of 55 squared is 55. 8 squared is 64. I'm going to move the square in the middle here. We move the square here. Whoops, there we go. We move the square here rather than keeping the parentheses, not here next to the t. That's different. This is the whole thing squared when you put it in the middle. If you just square the t, that's just squaring the t. All right, I'm going to subtract 55/4 on both sides. So 1 can be written as 64/64. And if I subtract 55/64, that gives me 9/64. And then if I take the square root of both sides, the square root of cosine squared, and don't forget your plus or minus, the square root of 9/64, I get the cosine of t equaling plus or minus 3/8. Now, since we're in the first quadrant, we have to think, hey, we're only going to have one answer. It's either going to be positive or it's going to be negative. And this side is going to be positive because it's a horizontal side going to the right from the origin. So the answer could only be positive. So the cosine of this particular angle is positive 3/8.